Alright, today we're going to be talking about conductivity types in battery materials. So there are conductors and insulators. You might ask what a conductor is. Well, we're going to go over two conducting type materials. And the first one is a metal wire, which is denoted as a rectangular kind of brownish box on the left side. And water. So you might not think of this as a conductor, but they're conductors and insulators in different ways. So first you might ask, what is a conductor? Well, conductors are materials where current flows via charge carriers. You might ask, well, what's a charge carrier? Well, charge carriers can either be electrons, such as that denoted as a yellow circle on the metal wire part, or ions, denoted as a green circle in the water. And so when we apply a voltage across a wire, this causes the charge carriers to migrate. And so when an electron can move through a material, this is known as an electric conductor. And so analogously, same thing when we apply it to a water, the ions will migrate across the water. And when you have ions that can migrate across water, this is known as a ionic conductor. So then we may ask, well, what are insulators? Well, insulators are materials where current cannot flow. And so looking back at the metal wire, one thing we might notice is, let's pretend that this is made out of copper. And this metal wire is copper wire. Well, copper wires are made up of copper ions, and there's an electron cloud surrounding it. And so one thing we might note when we apply this potential is that the copper wires do not migrate. And so this means that this metal wire is an ionic insulator because there is no movement in the flow of ions. And for the water, it is a poor conductor of electricity, so electric current. And so we'd say this is a electric insulator. And notice that we specify what kind of insulator or conductor this is. So for the metal wire, it is an electric conductor and put an ionic insulator. And water, when it has sodium or other ions in it, is an ionic conductor, but an electric insulator. Okay, and so, well, one may ask, well, is it possible for materials to conduct both electrons and ions? And the answer is yes. These are known as mixed ionic and electronic conductors, or MIEC, or just mixed conductors in the battery community. Graphite, denoted on the left side, with lithium intercalated, is an example of a good mixed conductor for battery applications. And so in order to check if it's a mixed conductor, we must see to satisfy a condition of being both an electric and an ionic conductor. If it satisfies both these, it is a mixed conductor. And so when we apply a voltage across graphite, well, we notice that the lithium ion migrates across. So this makes it an ionic conductor. So check. And so the next, we want to zoom into a single sheet of the graphite. And we notice that in a single sheet, that electrons can actually migrate across when a potential is applied to it. And so this makes this a good electric conductor. And to check. And so graphite for battery applications is actually a mixed conductor. Yay. And so to wrap it up, remember, conductors allow for charge to migrate. And so in water allows ions to migrate. So this is known as an ionic conductor. And for insulators, they don't allow for charge movement. And so remember, water does not move electrons. This is known as an electric insulator. And mixed conductors, which are important for battery applications, move both electrons and ions, as we showed in the graphite example earlier, as they both conduct electrons and ions. And so that wraps it up. I hope you enjoyed and learned something.